On this question, we are being given a limit here, and we're going as x goes to infinity. It's called an infinite limit as x goes to infinity. So the question is, what's the answer? If you just plug in infinity, it's not going to get you anywhere. Plug in infinity there, there. You're just going to get infinity over infinity. And you might say, oh, that's one. That's one. No, no, no. That's unclear. We don't know what that is. You might think, well, it's got to be. No, no. It depends how fast they go to infinity, right? All infinities are not the same. So, if you send two rockets up into space, if one's going way faster than the other, then the gap between them is growing. So we can't tell when you have a fraction. But basically, let me tell you this. What it's about is it's about the highest power on the top and the highest power on the bottom. That's all that really matters. So, in other words, what I'm saying is only this guy and this guy really matters. Why? Because this guy's a lower power than the 4x squared, and that's lower than the 9x. So you just, so I just, I'll say grab highest powers on the top and the bottom, in the numerator and the denominator. Okay, so then that becomes the limit. X goes to infinity of what? 9x over 4x squared. Just get rid of the rest of them. Um, Now, why is that all that matters? Well, let's finish it up and then I'll tell you that. So what is that? Well, that can be simplified. It's going to be the limit as x goes to infinity. That's just going to be 9 over 4x, right? Because x squared means xx. One of these cancels one of these. It's 9 over 4x. Okay, great. So what? Now plug in the infinity again. Now you get 9 over 4 times infinity. 4 times infinity is infinity. What's 9 over infinity? It's 0, and that is the answer. What now? A couple things. Why is 9 over infinity 0? Well, you know that, like, if you take 9 over a million, for example. What if I say I'm going to give you 9 millionths of a pie? I got a pie here. You can have 9 millions. That is basically 0, right? It's so small. Right? That means like 9 pies, but cut them into a million pieces. The piece you get is so small, and that's only a million. How about if we go to a billion, a trillion? Remember, we're going to infinity. So the piece of pie is headed to 0. And remember, a limit is where you're headed, not where you end up. You're getting closer and closer and closer to 0, right? You can prove now. It's important that you see this with numbers every now and then. Um, I know you might check out of the video at this point, but hey, let me show you. What if I take a fraction and I go 9 over and I do a million? 1, 2, 3, 4, 5, 6. There we go. Oh, it's going to show it that way, right? So yeah, right. Well, that's 9 times 10. That means point five zeros and a 9. And then if I add three more zeros, boom, boom, boom. Now it's 9 times 10 to the minus ninth. It's just that's eight zeros and a 9. It's just getting smaller and smaller and smaller. As I keep adding zeros, you see that number 10 to the minus 20. You remember that means the decimal's back 23 places. It's point 22 zeros and a 9. So you get it. We're headed to 0, right? Limit is where you're headed. So as that bottom goes to infinity and the top is just a fixed number, where are we headed? We're headed to 0. That's why the limit is 0. Now, back to the original. Again, you're probably checking out a video at this point, but let me just show you, why is the only the top power and the bottom power matter? Well, because if you're plugging in a really big number, let's do this one down here. X squared is going to be so much more dominant than the other guys. Let me show you. So what is that? 4x squared, 9x, and 3. Look for a second here. If I take 4x squared here, I'll do this, and I'll put in something like 1,000. Okay. And then I'll go 9x and I'll put in also 1,000. See how much bigger 4x squared is than 9x? You might say, well, it's negative 9x. Yeah, whatever. Okay. Oh, it's negative 9x. Still, that's what, 4 million compared to 9,000. And I'm only plugging in 1,000. What if I plug in a million? One, two, three. Oh, it's gonna, yeah, I don't, yeah, I don't want that. Let me erase some zeros here. What am I doing? Getting totally confused. Boom, boom. There we go. So what was that? That's 10,000. Okay, so I just added one zero. So boom, there's 10,000. Yeah, look at 10,000, right? That's, I don't know what that is, 400 million compared to 90,000. It's just getting way more. So as you go towards infinity, as x goes towards infinity, numbers with higher powers are going to dominate, right? And it's going to basically be, like let me put them together. What if I put in, let's put in a million. One, two, three. Wait. I thought I did prints in there. One, two, three, four, five, six. Here, yeah, okay, we'll put in a million. Squared minus 9 times x, which will be same thing, a million. One, two, three, four, five, six. All right, and then minus, what was it? It was 4x squared minus 9x plus 3. Minus 9x plus 3. Plus 3. Boom. Do you see that? It's basically that's almost four. See how the four is it's 3.99999. Basically, the four is dominating that scene. Do you see that? The four is dominant. The other stuff is like nothing. It's basically the four. So that's the deal. When you head off to infinity, the most powerful terms are all that matter. This 4x squared is going to dominate over these guys. Now, it's only because we're going to infinity. If we're going to any number, like just going to two or three or something, yeah, no, then they would all play an important role. But if you're going to infinity, the highest power are going to dominate the lower powers added and subtracted next to them. Same thing up here. This 9x will be way more than the 11. When you plug in a million, that's 9 million. A millionaire doesn't care about 11 bucks, right? Someone with 9 million or 9 billion doesn't care about 11 bucks. So there we go. Yeah. Now, having said that, here one last thing, which again you probably already long time checked out of this video. But here's the formal way. That's all just me kind of logically reasoning with you. But here's what you would do formally. You'd multiply top and bottom by 1 over x squared, I should say. 1 over x squared. Why? Because that's the biggest power. Here's how you would officially, formally prove it. You'd multiply top and bottom by the biggest power, which is x squared. So 1 over the biggest power, 1 over x squared. And so what do we get then? We get 9x over x squared plus 11 over x squared. And down here we get 4x squared over. I'm just again proving to you that this is really true. One more way, which is probably way more than you even want to see in this video. And then what's that going to be? Well, if you reduce those, it's going to be the limit. Oops. As x goes to infinity. Uh, what do we have left? So what's going to happen here? This will cancel this. This will be 9 over x. 11 over x squared. These are going to cancel 4 minus these are going to cancel again 9 over x, 3 over x squared. Now plug in the infinities. You see what's going to happen. This officially proves it. Plug in the infinities. You're going to get 9 over infinity plus 11 over infinity squared on the top. 4 minus 9 over infinity plus 3 over infinity squared. These guys are all zero. Because remember, anything over infinity is zero. So what's the answer? The top is zero, the bottom is 4, right? There's nothing left on the top, it's zero. 0 plus 0. The bottom is 4 minus 0 plus 0, it's 4. 0 over 4, 0. That's the official proof, but you don't have to do all that. Long story short, just grab the most powerful term, top and bottom, like I did in the beginning, reduce them, plug in the infinity, not of infinity, 0, done. I just wanted to show you why that's all true. And there we go.